Hello students, so in this lecture I'll be discussing the remaining problems that one may encounter while measuring a physiological variable in a living system. So what are the remaining problems? Already I have discussed the problems like I've already discussed in the problems like inaccessibility of variables, variability of data, lack of knowledge about interrelationships, interaction among physiological systems, effect of transducer on measurement. So these 5 problems I've already discussed. So the next problem that I'm going to discuss is artifacts. So what is artifact? Okay, you're going to measure a variable, a physiological variable from a human body. What will you do? You will use a transducer for measuring that human body. You will use a transducer for measuring that physiological variable from a human body. Now this transducer is going to represent that physiological variable in terms of a signal. So the signal the result will be correct when the signal, that is the output of the transducer, is actually the information of the variable that we are going to measure through the transducer. Now because of certain reasons, if some extra component gets added to that signal which is modifying the information of the variable, then that extra component is called artifact. What I am trying to say is that you have used a transducer to measure a physiological variable. Now because of the random noise generated within this measuring instrument, or because of the electrical interference or other unwanted variations, the signal that is the output of this measuring device, it contains some extra component because of these noises. Apart from the information of the variable, this signal also contains extra component which, because of this noises generated inside the measuring instrument or because of the electrical interference, etc. So these extra components, they are called artifacts. Now a major source of artifact that has been seen in measuring a living system is the motion of the subject, or you can say movement of the subject. Fine, it is the movement of the subject. How? Suppose you are using a transducer, you have already inserted a transducer inside the human body and you want to measure some physiological variable. Now because of the movement of the human body, or you can say here I'm subject, here subject I'm referring to as the human body, okay. So here because of the movement of the human body, what will happen? Movement of the measuring device or movement of the transducer will take place. Now many a times these transducers are motion sensitive, or you can say they are sensitive to movement. So the movement of the subject or the movement of the human body will produce variations in the output signal, or you can say unwanted result in the output signal. Now if I apply anesthesia to the patient on whom the measurement is to be made, if I am going to apply anesthesia to reduce the movement of the patient so that the transducer that is inserted in the patient may give actual results, so it is seen that this anesthesia may itself cause unwanted changes in the physiological system, and the variable therefore will be in its actual form, and the output that we will get will not be the desired one. So this is how artifacts actually introduces problems in measuring a living system. The next problem that I am going to discuss is energy limitations. Now how it becomes a problem? Actually what happens, many physiological measurement techniques, they require certain amount of energy for their measurement. we know many times many transducers or many measuring devices, they require certain amount of energy for their measurement. Now in case of human body, when these physiological measuring devices, they will be requiring certain amount of energy for their measurement, then that certain amount of energy has to be applied to the living system. For example, now I want to measure the resistance of a certain tissue. Now for measuring the resistance of a tissue, what I need to do, I need to introduce a transducer, and I need to flow the electric current through that tissue on whose resistance is going to be measured. So because of this flow of electric current, the transducer will generate certain amount of heat. Now in most of the cases, the amount of heat or the amount of energy generated by the measuring device is negligible, is insignificant. However, continuous care has to be taken, because we are actually measuring a physiological variable inside a living system. So continuous care has to be taken to avoid the possibility of energy concentrations that might damage cells or affect the measurements. What energy concentrations? The energy concentrations because of the transducer, because energy has been applied to the living system. So this is another problem another problem encountered in measuring a living system, this energy limitation. And the last one that I am going to discuss is safety considerations. So actually any biomedical engineer, when they are actually devising a biomedical instrument or a biomedical transducer for measuring a physiological variable inside a human body, so every biomedical engineer has to be extra cautious while designing such a measurement system, or while designing methods that are used in measuring variables in a living human system, in a living body, that in such a way they have to design that it should not endanger the life or normal functioning of the human body. So a biomedical engineer has to be extra cautious to design a biomedical instrument such that that biomedical instrument should not endanger the life of the patient or normal functioning of the patient, or you can say it should, the aim of the biomedical engineer is to protect the patient somehow, and the introduction of the measuring instrument should not somehow affect or deteriorate the health of the patient. So the measurement should not cause undue pain, trauma or discomfort unless this pain, trauma or discomfort becomes necessary so as to save the patient life. If it is at the risk of the patient life that we have to, the treatment will be painful or the treatment will be discomforting or traumatic, but it will save the patient's life, then it is okay. But in normal conditions, the devices so introduced inside the human body or so used for the human body for measuring physiological variables should not cause undue pain, trauma or discomfort, or you can say it should not endanger the life or normal functioning of the living system. So these were the problems encountered in measuring a living system. I am ending this class here. So one more thing I would like to say, so as you have seen that these are the problems that has been encountered in measuring a living system. So because of these problems, man instrument system was developed. So what is man instrument system? that I'll discuss in my next lecture. I'm ending this class here. Thank you.